Okay, continuing with my presentation, the last thing I need to tell you about normal distribution is applications. Again, we are going to distinguish between the three cases, and this is pretty much going to be exactly the same as standard normal distribution, but you will have different mean and different standard deviation. It's not going to be 0 and it's not going to be 1, so it's going to be an arbitrary normal distribution. Suppose that you have a Dixie office supplies, okay, and what we know is that the average driving time is 1200 miles per month per person, and the standard deviation is 150 miles. And we are assuming that the number of miles driven is approximately normally distributed. And we want to know what's the probability that the salesperson drives less than 1150 miles per month. So this is going to be case 1, because we're looking at the this would be the keyword here, this would be less than. So in order to figure it out, you're still using your norm distribution, and first you put the number. So if it's less than 1150, then you put 1150 first. Then it's going to ask you what's your mean and what's your standard deviation. And remember, for standard normal we were putting 0 and 1, but now this distribution is not standard normal anymore, so we're going to put whatever it is that they give you. So this is the mean, this is the standard deviation, and the last parameter is still 1, just like before, and this is what you get 0.3694. So demonstrating that real quick, in Microsoft Excel again, you would just click on any cell and type norm.dist, type the number 1150 first, then the mean, then the standard deviation, and then always type true at the end when you're talking about normal distribution, and this will give you the chance of being less than. So this is your case 1. And so whatever that is, that's your answer. So 0.3694. Now, case 2 is what's the chance that the salesperson drives more than that. So just like before, for case 2, we do 1 minus norm dist. We put the number, mean, and standard deviation, and then 1, and we get our answer. If we want to know what's the chance that the person drives between two numbers, just like before, we take the bigger number first. So which number of these two is bigger? The 1600. We find norm dist of that. So it'd be 1600, and then again mean, standard deviation 1. And then we're going to repeat the same thing with 1200, mean, standard deviation 1, and then we're just going to subtract. And so in Excel you can either type it as one big command, or you can type each one and then just in another cell just click equal and just subtract the two. The most important thing is you always start with the bigger number and then you do the smaller number, because the answer must be positive. So if you get a negative answer, that definitely indicates that you have switched them by accident. Okay, and then the final thing that what we want to do is we want to go ahead and talk about some percentiles. So I don't think I'm going to do this one because we'll be out of time, so I just want to do something like this. So suppose again, so you have a normal distribution, right? And so you have driving time 1200 miles on average, and standard deviation is 150. So this means that the mu is 1200 and standard deviation is 150. Suppose that you want to know what driving time would correspond to the fastest 10% of all driving times. So fastest 10% of all driving times. How would you do that? Well, you're using your favorite norm_inf function, so you're just going to type norm_inf, and then you're going to type 0.1, because, or 10%, that's fine, and then you're going to type your mean and standard deviation. That's all you need. Now, this would be the fastest. What about the longest 10% of all driving times? Well, this is going to be harder, because the longest 10% means that 90% of driving times are smaller than that. So what that means is now you're going to type norm_inf of 90%, 1200, 150. Well, we'll talk a lot more about this in class, but hopefully this gave you some idea so that you can do your homework.